Hi, I'm Cooper for Rack Robotics, and this is your brand new Powercore. Let's get it cutting. So opening up the box, you're going to find the Powercore along with a bunch of other accessories. That includes this piece of paper directing you to this YouTube channel as well as the manual. The enable cable, this lets you turn on the cutting function of the Powercore. Power cable itself, anode and cathode wires along with a Wago, stock material, brass electrodes, magnets, and a spare Wago. Now to make the best use of your Powercore, you're going to want to put it on a 3D printer. We've chosen the Ender 3 for ours, and you can get these 3D printable files on our printables page. The CAD is also available on our printables in case you don't have an Ender 3 or you want to put it on a different machine. If you do get the Powercore working on another machine, let us know. We'd be more than happy to include you and your files in the official release. So the machining vat itself is going to contain water. For that reason, we recommend printing it out of ASA and then sealing with acetone. This will keep all your electronics dry and free of problems. This part is the electrode holder cartridge. We'll assemble it now. Remove the Wago from the cathode wire. We'll then install it into the electrode holder cartridge. From there, we can install the cathode wire into the Wago. And then on the other side of the Wago, we'll install a brass rod. Install the assembled cartridge into the holder on the machine. Next, we'll take a piece of stock material that came with the Powercore and we'll install it into the work holder. This will allow us to hold the stock material steady and connect it to the circuit for EDM cutting. Take your work holder and remove both of the retaining clips. Place the stock into the recess in the top of the work holder and replace both retaining clips holding it tightly. Next, take the anode wire and connect that to the work. The entire assembly can then be placed into the vat. Fill the vat with enough distilled water to cover the work. It's important to use distilled water or deionized water, as tap water is too conductive for EDM. And with that, we're almost ready to cut. But first, everyone's favorite part, safety. The Powercore is a serious machine tool that uses high voltage, high power electricity to blast away material. With that comes certain hazards, and if used incorrectly, the Powercore can be very dangerous. Some basic safety precautions when using the Powercore include not touching the Powercore or the 3D printer while a cut is occurring, stopping a cut if a short occurs. The power resistor within the Powercore will tend to heat up. There are thermal safeties, but it's best and safest just to turn off the Powercore if you have that issue and attempt to restart the cut. Running cuts only when you have dielectric in the vat, and using the Powercore only on a GFCI outlet. For more detailed warnings, please refer to the manual. Great! Now that our motion system is set up, it's time to connect the Powercore. We're going to start by taking the power cable and installing that. This gets installed at the back of the machine. This is a good time to check that your power switch is switched to the off position. You can plug the other end into the wall now. Next, with the Powercore still turned off, we'll install our anode and cathode wires. These are installed into the front of the machine into the corresponding colors. Red to red, black to black. In this configuration, the Powercore still will not cut. This is a safety feature. It'll only turn on once 24 volts is applied to the 24 volt port at the front of the machine. For this video, we'll be using this lab supply to supply 24 volts to the enable, but you can use any source of 24 volts that you'd like. The only thing we recommend against doing is using the motherboard of the 3D printer. This has caused issues in the past. So we'll take the enable cable and we'll put it into the 24 volt port of the Powercore. We'll turn on the Powercore, listen for the fan, and then we'll turn on the supply. Now the Powercore is ready to machine. Next, we'll test the level of our workpiece. To do this, we'll run the Powercore and just barely touch the work to the metal by manually moving the Z-axis. You should see your first EDM sparks now. Move the rod across the surface and check that things are fairly level. It doesn't need to be as good as a regular 3D print because the rod moves well above the work surface. Adjust this as you would a normal print bed. Now we'll move over to RackRobo's CAM software, EDM Web. EDM Web is an open source fork of LaserWeb 4 that we modified to work well with EDM. We'll now cover how to slice a file. I've booted up EDM Web and I'm going to start by choosing my cut file. In this case, the EDM keychain on printables.com. You can see that the file appears in the machine volume. This file has an inside and an outside path that I'd like to cut, so I'll start by selecting the outside profile and changing its color. This will be important soon. Because there are inside and outside cuts, I'll drag the file down to the G-code section twice. We'll assign one as the outside and one as the inside. We'll now set both paths to the corresponding filter stroke color. So we'll hit Generate and you can see our G-code has been created. See how the depth of the tool consistently drops throughout the cut to compensate for tool wear. For your reference, the settings used for this cut are on screen now. Now we can take our code and try running it. Let's load up the file and see how it goes. And it's that easy. Now you can show off your awesome EDM keychain to all your poor friends who don't yet have their own desktop EDM machine. Thanks for following along. If you have any further questions, there's an active Discord chat linked in the description. Be sure to follow us on X for day-to-day updates on our EDM development efforts. Also, subscribe to this channel for future how-tos, projects, and product updates. Thanks for watching, and we'll see you next time.